So we discussed up to what part? Where means ABCD network was there. So have you revised that previous topic? Have you revised the previous topic? I think. Okay, no issue. So actually, yesterday I was discussing about the questions of the workbook. Okay, first you guys try to solve the problem, then only it's possible to discuss with you guys. Okay, just try once to solve those topics. Okay, right. Okay, so I think we already completed up to G parameter was done. Prasanna, G parameter we did it
Up to uh,
up to page.
1 second, I'll check.
Yeah, just check it.
Z parameters was
Over
completed.
now.
Yeah, it was completed.
Okay.
Up to Z we have completed.
Up to G we have completed. Okay. So let's
Yeah.
have. Okay, I will start from there then. We have to do ABCD parameter, right? So we have to start the ABCD parameter. Write the next heading. That transmission parameter. Fifth one. Okay. This is T, or we can say it as a ABCD or transmission parameter. Okay. Put the heading transmission parameter. So what is happening in this parameter, if we have, like, we can write it as a T, or that's not working. Let's do it. So we have T, or we say it as a ABCD parameter. So what is happening in this? We have some V1, I1. It is the function of V2, I2. So from here what we are getting, V1 and I1 is dependent parameter. It is dependent parameter. And what about V2 I2? V2 I2, it is independent parameter. Okay, so what I mean to say you, this V1 equation can be written as AV2 minus BI2. I1 can be written as CV2 minus DI2. This is the equation of a transmission parameter. Okay, so what we have to see in this, in a transmission parameter we have a two-port network. Okay, that is a network, that particular is current is going and from here current is coming. So suppose you have positive and negative terminal. This is V1 and from this the current will be like this. This is what? This is your I2 and I2 will come from this side. We write as a positive negative VR, that is positive negative V2, and we can say this as a sending side, so VS denote. These I2 can be in opposite directions IR current, receiving current, and it will be like that, means these IR. So IR is nothing but IR is equals to minus of I2. This is receiving current. Okay, or this is your I1 current and this is your I1 current. I1 is equals to IS. This is the sending end current. Okay, so in a two-port network, okay, so we have a network like this, means we can say, see, your equation was what? V1 is equals to A V2 minus B I2. I1 is what? CV2 minus DI2. So same equation you can represent. V1 is nothing but Vs. So Vs is equals to A V2, you can write VR, or instead of minus I2 you can write IR plus BIR. Same, instead of I1 you can write IS. To C, instead of V2 you can write VR, and instead of minus I2 you can write IR, so it is DIR. So this is the equation of ABCD parameter. So what will the value of A? What can we comment? The value of A is equals to V1 by V2 while keeping I2 is equals to 0. Okay, so this is known as what? This is known as open circuit. This is what? This is open circuit. Open circuit reverse voltage gain. Reverse voltage gain. What about your C? C will be this is C. It will be I1 by
I1 by V2,
I1 by
I2
V2.
equal to 0.
I2 is equals to 0. So this is what? It is open circuit,
Open circuit,
reverse transfer admittance, because this is admittance. In the previous class I told you 1 by Z is nothing but admittance, and Z is what? Impedance. Z is equals to V by I. For admittance it will be this is Z, and for admittance it will be I by V. So that's why it is I by V. So it is open circuit reverse transfer admittance. Okay. What about D? A is done, C is done. What about B? B will be V1 by minus I2. Okay. B will be what? If you want to find the B, so V1 by minus I2, it will give you B. Okay. While making V2 is equals to 0. So this is short circuit V1 by I2. That means V1 by I2 is coming. It means what? It is reverse transfer impedance. Reverse transfer impedance. Okay. What about D? D is I1 by minus I2. V2 is equals to 0.
Sir, can you just explain me why you are taking admittance and impedance? How you are taking that? One second.
See, in this question it's automatically means you are not getting the what is the difference between admittance and impedance.
And how you are considering that I by V as an admittance, like V by I as an impedance?
Admittance, the meaning of admittance is nothing but it is just like a impedance is what? Impedance is the combination of resistor, inductor or capacitor, okay, in the form of reactance. So R plus JXL plus JXC is nothing but it's like a impedance, and impedance you can see it's like a resistor. What is the basic formula of a resistor? R is equals to V by I. Okay. And what will be the if you will means your R is equals to V by I. In terms of Z we can say it's as the same V by I, but if you will consider 1 by Z is equals to, it will be I by V, right? 1 by Z is equals to I by.
Yeah, got it.
So these 1 by Z means what? It is I by V, and this 1 by Z is nothing but it's admittance only.
Admittance.
So that's why we are considering here. Okay. And
Yeah,
this
okay.
D is I1 by I2. So I1 by I2, when V2 is equals to 0, it will be short circuit reverse current gain. Short circuit reverse current gain. Okay. So this was the admittance means transmission line condition. Write down the condition of a symmetricity. Now we are moving to another section. Yeah. Wait. Write down condition of symmetry. Symmetry. What could be the condition of symmetry in network? So this is your network. So what can be the condition of a symmetry? Symmetry means what? So for that Wait, just wait. It's not. It's my pen is stopped working. That's why. So condition of a symmetry. Condition of a symmetry means. See, suppose you have. I already told you that z parameter. The equation of a z parameter was what? Z parameter is equals to v1 is equals to z11 I1 plus z12 I2. You remember na this? And v2 is equals to z21 I1 plus z22 I2. This was equation 2. Okay. So the meaning of this is nothing but just you have a network. This is a two-port network. This meaning is what? Some I1 current is coming and from here some I2 current is coming. Okay. Now suppose in this you are connecting a load like means voltage like V of S, and this is your positive negative V2. So this is what? This is V1 is equals to Vs. Okay. Now you are assuming this circuit is open. The circuit is open means the no current will flow. You are assuming I2 is equals to 0. Okay. And while substituting this in equation 1, what you will get? Vs is equals to Z11 I1 plus Z12 into 0. Someone came. Okay. So yeah. So what I am telling, you are assuming Vs is equals to Z11 I1 plus Z12 0. So while solving this, and if you will go for the equation 2, and while solving this, what you will get? Vs by I1 is equals to Z11. Okay, this is your equation 3. Okay, this thing is clear. And you will do the second assumption is you are taking the same network. This is V1 side, this is I1 is equals to 0. You are making right, and now you are, this is your I2 and this is I2, and now you are connecting the supply this side, same supply. Means what I am telling, you have a network. First you connected the supply in this part, okay, in this side it is open, and you put the current is as a 0. You are getting Z11 is equals to Vs by I1. So what you did, you remove this part, you remove the battery source, and you connected the battery source this side. Okay, and here you are making the port I1 current is 0. Now you are substituting the value in which equation? You are substituting the value in equation 2. Okay, so what you will get? Equation 2, what is our equation? V2 is equals to Z21 I1 plus Z22 I2. So V2 is equals to Z21 I1 plus Z22 I2. This was the equation 2. Now see the value of a V2. V2 value is Vs, and I1 you make it as a 0 because it's 0. You are getting Z22 is equals to I2. So what is the value of a Z22 is equals to Vs upon I2. Okay, this is equation 4. So for symmetricity, this condition, symmetricity, these equation 3 and equation 4, if equation 3 and equation 4 is coming equal, then the network is symmetry. What I am telling, if equation 3 and equation 4 is equal, then your equation is symmetry. So that meaning Vs upon I1 when your I2 is equals to 0 is equals to Vs upon I2 when your I1 is equals to 0. This is the symmetricity property. Okay, so write one note. From equation 3 and equation 4, Z11 is equals to Z22 if we are getting. So this is the property of a symmetricity. Same thing is applicable for what? It's applicable for Y22 parameter, means y matrix. What was the condition of a Y matrix? If we want to convert the Z11 into Y matrix, so what was the coming? See the previous note, we are getting as a Y22 divided by determinant of Y. And what is Z22 equivalence to? Y22 divided by, it will be Y11. Y11. This is Y11. Y11 divided by determinant of Y. So if you want to convert Z11 in terms of a Y admittance matrix, it will be Y22 divided by determinant of Y. And if you are converting Z22 in terms of a Y matrix, so it will be Y11 divided by determinant of Y, valid for symmetricity. Okay. And this was the condition for symmetricity, means you are taking one network, what you are doing, you just solving the circuit with the help of this, and you are making the current I2 is equals to 0, substituting the value in equation 1, you are getting Z22 value, Z11 value is Vs by I1. Same thing what you are doing, you are removing this Vs supply and adding this Vs supply to second port. Okay, and now you are making the I1 is equals to 0 and putting the equation in equation 2 in this equation. And if you are getting the equation Z22 is equals to Vs by I2, suppose it's have some value. If these equation 3 and equation 4, if these equation 3 and equation 4 are same, so the network is symmetricity. Okay, so Vs by I1 is equals to, we are assuming this as a same, so that means Z11 value, this is what? This is Z11 only now. So Z11 value is coming as a Z22 value. This means your network is symmetricity. Okay, so what do you mean by this? Is nothing but you have a network, this is Z11, this is Z12, this is Z21, this is Z22. For symmetricity, this particular value should be equal. Z11, if Z11 is equals to Z22, the network is symmetricity. Understood? Prasanna, understood?
Yeah.
Okay. And while converting this Z11 into Z12, Z21 into Z22, what I had said to you, if you want to convert this matrix in a Y matrix, this is Y matrix is what? It's the inverse of a Z, right? So what will
1
come?
by Z.
Yeah. So Z22, Z11, this will be
Minus
Z1
Z12
minus Z21. Yeah, correct.
minus Z21.
Determinant of mod Z. determinant divided by. So this is your this is what y11 y12 y21 y22. So you are getting y11 is equals to z22 by determinant of z, and y22 you are getting z11 by determinant of z. Okay, so this is the story for the y matrix. Now write the notes for condition for reciprocity. In the same manner what we did, condition for okay, write the note. A network is said to be reciprocal if the ratio of response to excitation remain same even when their position are interchanged, even when their position are interchange. Okay, so what I means to say you that if you have a two-port network like this, V1 is equals to Z11 I1 plus Z12 I2, and you have V2 is equals to Z21 I1 plus Z22 I2. This is equation 1, this is equation 2. So for seeing the reciprocity, what you have to do, you have to make the two-port network first. So suppose we have a two-port network like this. Okay, this is your two-port network. So what I am saying, see, you are assuming positive negative V of s here. This is nothing but it's your V1. Current I1 is going and current I1 is coming from this. What you are doing, I2 current it's coming like this and I2 current it's going like this. Okay, here what we are doing, we are short circuiting the circuit. We are doing the short circuit. That means plus minus V2. If short circuit is there, then its value V2 value is 0. Okay, so from here V1 is equals to Vs, V2 is equals to 0, and we are means suppose we had made some current here like this I2 dash, it opposite to this current, means your I2 is equals to minus of I2 dash. Okay, so write the equation 1, Vs is equals to Z11 I1 minus Z12 I2 dash. In place of I2 I have written minus I2 dash because I have taken a direction opposite to this in a same branch, in a same loop as a new name I2 dash. Okay, so if you will go for the equation 2, your V2 value is 0, this V2 value is 0, and it is equals to Z21 I1 minus, again I2 dash will come, because in place of I2 I am writing I2 dash, minus Z22 I2 dash. So from here, from this equation, uh, we can find the value of I1. So I1 is nothing but, from this equation, this is equation 4, this is equation 3. So we are getting the value of I1 is what? I1 is Z22 I2 dash upon Z21. This is the value of I1. Okay. So yeah, this take this is as a equation 5. Okay. So with the help of equation 5, substitute the value here. Vs is equals to I1 value. What we'll get? So here we are getting Z21, right? So what I1 value, if we'll substitute the I1 value here, what we'll get? Z22 will get like this: Z11 Z22 divided by Z21 I2 dash minus Z12 I2 dash. Take the comma I2 dash I am taken common. So what we are getting? Z11 Z22 minus Z12 Z21 divided by Z21. So the response is coming what? The response. This is nothing but this is your determinant of Z. Okay, so Vs upon, or we are checking the response. So I2 dash upon Vs is what? Z21 divided by determinant of Z we are getting. This is your determinant only, na? Z11 into Z22 minus Z12 into Z21. If you will draw the matrix, you are having Z11, Z12, Z21, Z22. So this is coming like a determinant. What we did, we actually did the equation of a Z parameter is what? V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. Here in the first case, what we are doing, we are just making it as a short circuit, and we are taking some current like this I2 dash in this direction, in a downward direction, and these direction are opposite. That means your I2 dash is nothing but I2 is nothing but it's equals to minus I2 dash. Now substituting this value in both equation 3 and equation 4, we'll get the value of a I1. So we are getting the value of a I1. This. If we'll substitute the both value in equation 1 and equation 2, we'll get equation 3 and equation 4. From equation 4, we'll get the value of I1 like this, Z22 into I2 dash divided by Z21, and substitute the value in equation 3 again. And you will get Vs is equals to in terms of like this. And you are taking a common of a I2 dash divided by Vs. So this is the statement. See the statement. A network is said to be a reciprocal if the ratio of response to excitation. So this is our response. How response? Because we are getting output as a I2 dash, and excitation is what? V of s. So we are getting I2 dash divided by V of s is equals to Z21 by determinant of Z. Z11 into Z22 minus Z12 into Z21, it's your determinant only. Now another case, what is written? Same even when these positions are interchanged. Now we will go for the second case. Second case is like, we will take the same network. Now these part will get, this is your I1, this is your I1, this is positive negative V1. You are short circuiting this side, means interchanging. You are bringing this here and bringing this here. Okay, this is known as interchanging. So we are interchanging, and this we can make it as a I1 dash. So I1 dash will be equals to what? Minus I1, because the position is different. Okay, this is I2, positive negative V2. Now you are connecting positive negative V of S. So from here what we are getting, your V2 is V of S, your V1 is equals to 0, your I1 is equals to minus I1 dash. Okay, now substitute the value in equation 2 and equation 3. You will get V of S is equals to minus Z21 into I1 dash plus Z22 I2. Why minus? Because we replace I1 as minus I1 dash. Okay, now put the value in a equation in this equation. So what you will get? In a equation 1 we put the value in a equation 2. Now put the things in a equation 1. Your V1 value is what? Your V1 value is 0. Wait. Your V1 value was 0. So V1, if V1 value was 0, then substitute the 0 value, get the minus Z11 I1 dash minus I1. Instead of I1 writing minus I1 dash, and here I miss the things, Z22 into I2. Here it will be Z12 into I2. Now what we have to do, we need to find the value of I2. So what will the value of I2? From this equation we'll get, take it as a equation 6, we'll get from this equation from this equation we'll get the value of I2. I2 value will be Z11 divided by Z12. Okay, Z11 divided by Z12 into I1 dash. Substitute the value in equation 6. So you will get Vs is equals to minus Z21 divided by Z12 into Z11. We are substituting the value of I2. Oh, let me correct it. So we have minus Z21 I1 dash, and we are placing the value of I2. I2 we got Z22 into Z11 divided by Z12, and we have I1 dash common. So we are taking what? We are taking I1 dash as a common. We are getting what? Z12 into Z21 minus is there, plus Z22 into Z11 divided by Z12. So now check the response. Response means, check it like this. So you are getting I1 dash divided by V of S is Z22 to Z11 minus Z12 into Z21 divided by Z12. This is nothing but it's a determinant only. So I1 dash divided by V of S is equals to determinant of Z divided by Z12. So this is in this question we did I2 dash divided by V of S, and this with this I1 dash divided by V of S. So we are getting what? We are getting we are getting mod Z divided by Z12, and here what we are getting? Z21 divided by mod Z. So here this is your output side, okay, and this is your input side. See, so in a transfer function, what is the output upon input we have to see. Okay, now excitation is what? Your excitation, your response is what? Your response and excitation. So in this case, you have to see Vs upon I1 dash, and that is nothing but Z12 divided by mod Z. Means always as a transfer function we are seeing as a output upon input. Okay, see this case. We are seeing this is I2 dash is our output, and input was V of S. Okay, and in this case, what is our output? Output is V of S, and what is input? I1 dash. So output upon input, output is V of S divided by I1 dash. In a Z parameter, always your Z11, Z22, Z12 or Z21, always these Z12 and Z21 will always equal. And this Z11 and this Z22 will always equal. It either it may be equal or it might not be, but this is not true, but this will always happen. Z21 or Z12 will always equal. So what I am saying, even if it is equal, that means your Z12 can be written as Z21 divided by mod Z. So what you did means check the result. You are getting the, and Z21 is equals to Z12, so it is Z12 divided by mod Z. So what we are saying, while changing the response or excitations and response, we will get the same answer for output by input. That is your ratio, same even when the positions are interchanged. Response to excitations remain same. So response to excitations is coming remain same. It's clear, or any doubt in this part? Anyone having any doubt? Prasanna, clear?
Yeah.
Okay. So while solving the question, you will understand more perfectly. Oh, okay. So see what I am telling. Make a note like this. In your first network, you are getting I2 dash divided by V of S. This was what? This was your response, and this was what? This was your excitation. This we done for network 1. It is equals to V2. Yeah. So the things we are getting the same thing we are getting. Okay, I1 dash divided by V of S. Okay, so I1 dash divided by, oh sorry, I just did a mistake here, I'm really sorry. So you will get means I1 dash divided by V2 dash, it's coming as Z12 divided by Z22 into Z11 minus Z12 into Z21. So means I by V ratio is coming same in both the places. So output means output upon input, the response to excitations is coming same. So I just want to explain you again once, just see it. So condition for reciprocity is what? A network is said to be reciprocal if the ratio of response to excitations remains same. So excitations generally excitations means voltage, what the voltage we are supplying. So in the first case, what was our voltage, Prasanna? What was our voltage? V of s, right?
Mm.
V of s. And response what we are getting? I2 dash. So V of s is our excitation, and response what we are getting? I2 dash. Okay. So what is written? The ratio of response to excitation. These response divided by these excitations will always same if we interchange the supply also. So by solving this, we are getting the value of I1 like this. We got the value of I2 dash divided by V of s is equals to Z21 by mod Z. Okay. In the second case, excitation will always be voltage. So this is excitation only, and this is response. Okay. Now by solving this also, wait, someone is coming. So by solving this also, Prasanna, we are getting what? This is our excitation. This is our response. By solving this, we are getting the same value. Z12 divided by Z22 into Z11 minus Z12 into Z21. So the condition of this is just a condition of a reciprocity. Okay, that is the condition of a reciprocity. So write the important notes. You just need to remember what? You just need to remember only this thing. For reciprocity, you have to check. For reciprocity, what you need to check? You need to check Z21 mod of Z is equals to Z12 mod of Z. If this condition is applying, that means your network is reciprocal. You have a Z parameter Z11, Z12, Z21, Z22. Apply the see the conditions, means see this value, see this value Z12 value and divide it by its determinant. Then see this value Z21 and divide it's by determinant. If you are getting the same result, that means the network is reciprocal. Okay. And we know the relation between Z parameter and Y parameter. So the result will come for a Y parameter is minus Y12 divided by determinant of Y. Determinant of Y will get. Okay. So determinant of Y will get is equals to Y21 divided by determinant of Y. This will be minus sign, because this is Z11, Z12, Z21, Z22. So this is the inverse relation. So if you will do your Y parameter will be Z22, Z11 minus Z12, and this is minus Z21 determinant of Z. Okay. Even if you are seeing your Z parameter in terms of Y parameter, see Y11, Y12, Y21, Y22. If you want to see it in terms of a Z parameter, so inverse, that is your Z only. So if you are inversing, what you are getting, this is Y22, Y11 minus Y12 minus Y21 determinant of Y. So compare this result with Z11, Z22, Z12, Z21. and put the value in this z21. z21 z21 is what? z21 is nothing but it's minus y21 divided by determinant of y. So that's why it's coming minus y21. This is minus sign, minus y21 divided by determinant of y. z12 is what? z12 it's minus y12 divided by determinant of y. So we are getting minus y12 divided by determinant of y. So this is the conditions you should know. Okay, so for reciprocity, write a crux, important point. For reciprocity, you should have z12 is equals to z21. Okay, and for this is applicable for what? Applicable for Z matrix. And if you want to see for the admittance matrix, same result will come. y12 is equals to y2, and this is applicable for Y matrix. This is the condition for reciprocity. And for symmetricity, z11 is equals to z22. This is for Z matrix. And y11 is equals to y22. This is for Y matrix. So this is important. Only this part is important. If you are getting the Z matrix, and if it's satisfying this result, then the matrices are, then the results are, then the network are your reciprocal network. If it is satisfying this result, then the network are symmetrical network. Okay, so from this write one or make one diagram. Let me give you, suppose you have a T network. This is Z1 and this is Z3 and this is Z2. So what I am saying, this is your port 1. Okay, this is your port 1, this is your port 2. So if it is my port 1, then it is V1, then it is V2, current is I1, and from this current is I2. If I1 current is this, if I2 current is this, the net current will flow in this will be I1 plus I2. Okay, if you will form one loop equation here, you will get a result V1 is equals to Z1 I1 plus I2 into Z2. So result is coming Z1 plus Z2 into I1 plus I2 Z2. This is equation 1. Similarly, if you will form one KVL equations in this loop equation, what you will get, V2 is equals to Z2 I2. This is Z2. Let me stop the working again. Okay, so Z2, this is I2 plus you are getting Z1 plus this is Z2. Okay, in this is what? Wait. Yeah, this is your I1 plus I2 into Z2. You are forming a loop equation, generally loop equation. This is the loop equation. So I1 plus I2 is coming with the Z2. You are getting V2 value is Z2 plus Yeah, you are getting this only, na? Or something. Oh, sorry. This upper part is Z3 now. I committed mistake here. This is Z3. So you are getting Z3 plus Z2 into I2 plus Z2 I2. Okay, this thing is clear. We are getting the Z matrix from this is what? See, this is your Z11. Compare the result. Compare the result. V1 is equals to Z11 I1 plus Z12 I2, and V2 is equals to Z21 I1 plus Z22 I2. So this is Z11, this is your I1. So what is the meaning? This Z1 plus Z2 is your Z11. So Z1 plus Z2, and Z12. Z12 is what? And this is I2. Its Z2 value is your Z12. Z2 value. Okay? And Z21 value is what? Z21. Z21 value. This is coming with I1. Okay? This part is your I1 only. I1. I1 is, this is I1 only. So Z21 is what? Z21 your is Z2. And what is this? This is Z3 plus Z2. So see what you are getting from here. This part is equal now. Z12 is equals to Z21. So the network is what? Reciprocal. Am I correct? Reciprocal. From the previous result, what I told to you, for a reciprocal network, your Z12 must be equal to Z21, and we are getting the same. Z2 is equals to Z2, and for symmetricity, this could be equal to this. If Z1 plus Z2 is equals to Z3 plus Z2, then this could be a reciprocal network. So we have Z2. If your Z3 value is coming as a Z1 value, then only the network will be symmetricity. Prasanna, you have any doubt in this? Or it's clear? Or shall I repeat it again?
Yeah, once again.
Once again you want. See what I am telling. This is a, let me draw once again, then only it will be understood properly. What I am telling, we have some network, T network. Okay, this is your T network. So in T network, I1 current and here I1 current is coming back. This is I2 current, this is I2 current. Okay, it's a positive negative V1, this is your positive negative V2. Some register whose value is given as a Z1. Okay, and here some register it's given as Z2. Here it is given as Z3. If you will apply, see, I1 current is coming from this side and I2 current is coming from this side. So what will the net amount of current? I1 plus I2. KCL, applying the KCL, we are getting the result I1 plus I2. Now follow, now make the KVL loop. You will get minus V1 plus I1 Z1 plus I1 plus I2 into Z2 is equals to 0. Okay, so what you will get? V1 equation. You will get V1 equation is what? This is common. This Z2 into I1 will give you I1 into Z1 plus Z2, and this is I2 Z2. This equation is clear, Prasanna?
Yeah.
Or doubt? Any doubt? Any doubt? Just if any doubt is there, then you can ask me. Or it's clear. This equation is clear for you. If it's not clear, you can ask.
It's clear.
It's clear. Okay, same operation you have to apply for this part. Okay, so what you will get, just tell me what you will get. You will get minus v2, i2 is going, so plus i2 into z3 plus i1 plus i2 is coming, i1 plus i2 is coming, it will be multiplied with what, z2, will get result 0. So v2 will, what we will get the v2 value, here i1 is here also, and this is i2, this is i2. So i2 is here also and i2 is here also, so we are taking a common i2, we are getting z3 plus z2, and we are getting z2 into i1. So compare the results with the original equations. Your v2 is equals to z21 i1 plus z22 i2. So just watch it. These equation, this is your general equation of Z impedance. So your Z1 value is what? If you compare this, your Z1 value is what? Z1 value is Z1 plus Z2. Clear, Prasanna? And Z12 value you are getting Z2. Okay? And if you will compare this value with this equation, where is I1? I1 is here. Okay, so Z21 value is what? Z21 value is Z2. And what is the value of a Z22? It's Z3 plus Z2. Z3 plus Z2. Make the matrix Z11, Z12, Z21, Z22. What I told you, for a reciprocity, these diagonal element, these off diagonal elements Z12 and Z21, if these two are equal, then the network is reciprocal. And if these diagonal element Z11 is equals to Z22, then this is for symmetricity and this is for reciprocity. So put all the value. Z11 value is what? Z1 plus Z2. Z12 value is what? Z2. Z21 value is what? Z2. Z22 value is what? Z3 plus Z2. So see, this we can clearly see it is equal. So that means what? This network is reciprocal. So we can directly comment our network is reciprocal network. But for symmetricity, this should be equal. So what we are getting? We are getting Z2 here. But here we are getting Z3 terms and Z1 terms. So if Z1 is equals to Z3, then we can say Z1 plus Z2 is equals to Z3 plus Z2. Then the network is symmetricity. Okay. So if these and these are same, then only we can say network is symmetricity. Like I can show you some example. You have 1 ohm here, you have 2 ohm here, you have 3 ohm here. So by taking one mirror, you are getting the same thing here and here. No, not. You are not getting the same thing. This is Z1 and this is Z3. But if I'll say I am getting 3 ohm here and I am putting 1 ohm resistor here and making this as a 1 ohm. So now if you will put a mirror, you will get the same replica to this side. So that is the symmetricity. Okay, Prasanna, it's clear? Prasanna? Is it clear or any doubt? Anish, is it clear? Priyanka, is it clear?
Yes, sir. Yes, sir.
Okay. So, okay. Yeah, same thing we will do it for. Yeah. So write one important. First, you have to write one important notes. Just make one box and Z11 is equals to Z1 plus Z2 Z12 is equals to Z21 is equals to Z2 in T network. It is applicable in T network only. And Z22 is equals to Z2 plus Z2 plus it's Z3. This is 3. Okay, so this is applicable in T network. This is a shortcut for a T network. Okay, if you are getting the network like this, you can directly find your Z11 value, Z12 value and Z22 value by substituting this form: Z1 plus Z2, Z22, and this is Z2 plus Z3. Okay, now we'll go for pi network. Okay, pi network. So pi network look like, for pi network we'll analyze for a y network. So suppose you have some admittance and this is we are talking in this network we are talking about what? We are talking about admittance, not impedance. Okay, we are talking about admittance. So this is, assume this is y1, assume this is y2, and assume this is y3. Remember, means see your notes and check it. I had given you the lecture on that. Means for a admittance parameter, this is I1, this is I1. We are taking the same concept. V1, this is positive, negative, V2. If I2 is going, I2 is coming. Okay. So what was the general equation of a y parameter? What was the general equation of a y parameter? I1 is equals to y11 v1 plus y12 v2, and I2 is equals to y21 v1 plus y22 v2. This is the general equation of what? Equation of y admittance matrix. Okay, so see, so this is nothing but this is v1 only. Okay, v1 only, that point, and this is nothing but this is your v2 only. And apply the junction node. Means some current, if you are seeing some current like this, some current like this, some current like this, and some current like this. Apply the node on junction J1. This is assume J1, and this is, you assume J2. If you will apply the nodal, what you will get? I1 current is coming. Okay, I1 current is coming, and these two currents are leaving. So I1 current should be equal to, and we are taking this as a ground, V1 upon Z1. That means V1 into Y1, because 1 by Z1 is equals to Y1. Okay, so V1 Y1, we got this branch current. What about this branch current? These will be minus with this. So V1 minus V2 upon 1 by Z2. And what is 1 by Z2? 1 by Z2 is equals to Y2. So we are simply writing
Y2.
Yeah, Y2. So we are getting, just solve this equation and get the result. If you solve the equation perfectly, what you will get, take the V1 as a common, Y1 minus Y2 plus Y1 minus Y1 minus Y2. This will be V2. Okay, and this is your Y1 V1. Am I correct, or I did some blunder here? Just check it. V1 Y1 is there. V1, oh yeah, I'm sorry, I committed some mistake. So see this part, V1 is common. Okay, so you have to make the V1 as a common, so you will get Y1 minus Y2 and minus Y2 into V2. you are getting the equation of I1. Okay, this is equation 1. Same thing you have to apply for junction J2. So what will be the answer? I2. I2 is the net. I2 is the incoming I2 is the incoming current. So I2 is incoming current. What is this current? This is outgoing current, and this is also incoming current. Incoming current. So if incoming current is this, then I2 plus V1 minus V2 into Y2. What is the outgoing current? This V2 minus 0 into Y3, right? And if you solve this, what you will get? I2 equation is Prasanna, what you will get? I2 is, just tell me. I2 equation like this. You have to tell like this. What we are getting, I1 is equals to V1 into Y1 minus Y2 into V2. So if you solve these equations, what the results will get? We will get V2 minus V1 into Y2 plus V2 Y3.
V2 Y2.
V2 Y3. How Y2? I2.
Sorry, Y2.
Yeah. If you will take the V2 as a common, if you will take the V2 as a common, so what will come? Y2 plus Y3, right? And this is minus V1 Y2. So I2 is minus V1 Y2 plus Y2 plus Y3 into V2. We are getting like this. You all guys are getting like this. See, Prasanna, in this first equation, this will be plus, okay, because this is y1 v1, this is, if you will take it common, so plus will come. You guys didn't said here plus will come. If you will take it common, so plus will come. So what the equations we are getting, just write it down, the general form. I1 we are getting as a V1 Y1 plus Y2 minus V2 into Y2, and I2 we are getting as a minus Y2 into V1 plus Y2 plus Y3 into V2. Compare the result. Y11, Y12, Y21, Y22. Okay, if you will compare this result, what the value we are getting? Y11 is Y1 plus Y2. Y12 is minus Y2. Y21 is Y21, this is Y21. So Y21 is minus Y2. What about Y22? Y22 is Y2 plus Y3. Now can anyone say me, is the network is reciprocal? Is the network is reciprocal? See this condition. For reciprocal, these to be matched. Y12 and Y21. So we are getting it's matched. So in every pi network, every pi network is a reciprocal network. But it might be symmetry, it might not be symmetry. Similarly, every T network is a reciprocal. It might be symmetry, it might not be symmetry. Okay? Because for symmetricity, it totally depends upon, this is reciprocal. And for symmetricity, it's totally depend upon which value? This Y3 and Y1 value. If Y3 is equals to Y1, then only the network will be symmetricity. Okay? So this is the shortcut method, and means like if you understood. Anyone having any doubt in this up to this part, or it's clear? If anyone is having a doubt, they can ask.
No, sir.
Okay, so just solve the question I'm giving you one question. Just try to solve it. Section. Now, in this question, you need to find z parameter, y parameter, and h parameter, z parameter, and t parameter. Okay. Question is find z parameter, y parameter, h parameter, g parameter, and t parameter. All parameters you need to find z, y, h, z, and t. Okay. Parameter and the network. Your network is this is your network. It's 10 ohm. It's 3 ohm. This is positive negative. It's 4i1. Dependent source is given. Okay. And this is it's 2 ohm. Okay. And this is your positive negative V2. It's I2. It's I2. Positive negative V1. This is I1. So you have this network and you need to find your Z parameter, Y parameter, H parameter, Z parameter, and T parameter. So Prasanna, what is the general equation of a Z parameter? Right now we discuss what is the general equation of a Z parameter. V1 is equals to Z11 I1 plus Z12 I2. V2 is equals to Z21 I1 plus Z22 I2. This is for Z parameter. What is the general equation for Y parameter? I1 is equals to
I1 equal to Y11 V1 plus Y12 V2.
Y12 V2 and I2 is equals to
Y21 V1 plus Y22 V2.
I21 V1 plus Y22 V2. Okay. So this is Z parameter, this is Y parameter. What about H parameter? We already discussed in the previous class. What is the general formula of a H parameter? Anyone? Guys, this thing should be in your mind. Write it down. V1 is equals to H11 I1 plus H12 V2 and I2 is equals to H21 I1 plus H22 V2. This is the general equation of a H parameter. And for G parameter, use the duality. V will become I will become V, and H will become G11 V1 plus G12 I2 G21 V1 plus G22 I2. This is I2. So this is the equation of G parameter. And right now we discuss about the T parameter, ABCD parameter. So I know you guys know what is the general equation of a ABCD parameter. V1 is equals to AV2 minus B I2 and I1 is equals to CV2 minus DI2. So these equation we know, and we know the conditions, and by seeing this, what kind of a network is this? It's a T network, na?
T network.
Yeah. Okay. But the problem here is that we have what? We have one dependent source, right? we have one dependent source. Am I right? So how to solve this dependent source? So how to solve this dependent source? Wait, let me take. Yeah, how to solve this dependent source? It's very simple, yaar, very simple. See, this I1 and this is I1, so it's depending upon the value of I1. You don't need to do anything. I1 current is this, I2 current is this. So what will the overall current? I1 plus I2. Apply the KVL, get the result. Minus V1, 3I1 plus 10 into I1 plus I2 is equals to 0. So V1 is equals to 13I1 plus 10I2. You got equation 1. Apply from here another equation. You will get V2 is equals to 2I2 minus 4I1. Let me solve like this. It's minus V2 is equals to plus 2I2 minus 4I1 minus 4I1 plus 10 into I1 plus I2. Okay, so right, it's 10 I1 plus 10 I1 plus I2. So what you will get? V2 is equals to, solve it and just tell me the results. 2, 10, 12 I2 we are getting, and 6 I1. See the calculation part. So 6 I1 plus 12 I2. Compare this equation 2 with your general equation. V1 is equals to Z11 I1 plus Z12 I2. V2 is equals to Z21 I1 plus Z22 I2. Compare this equation with this with this, get the result. So Z11 is what? It's 13 ohm. Z12 is how many ohms? 10 ohm. Z21 is how many ohm? Z21 is 6 ohm, and Z22 is 12 ohm. So you got the Z parameter, right? We got Z parameter is 13, 10, 6, 12. If anyone can ask you whether this Z parameter, whether this network is reciprocal or symmetry, what you will comment? It is neither reciprocal nor symmetry, because this value is for reciprocal, they are not matching, so it's not reciprocal, and this value is for symmetricity, it's also not matching, so this network is neither reciprocal nor symmetry. Okay, now you know the value of a Z, that is 13, 6, 10, 12. Z is nothing but Z is 1 by Y. So Y is nothing but Y is Z inverse. Find the inverse matrix, you will get the Y parameter. So if you will find the inverse matrix, it will come 12, 13, minus 10, minus 6. The value will be divided by 13 into 12. 13 into 12 is how much? Tell me the determinant. 13 into 12 minus 60. 96 we are getting. Okay. So overall result will be 12 divided by 96. 12 divided by 96. It's 0.125. And minus 10 divided by 96 is 0.104, minus 0.104, minus 0.104. 4 and minus 6 divided by 96, we are getting minus 0.
65.
Minus 0.0625, right? And 13 divided by 96,
0.135.
0.135. 0.135. So this is your y parameter. Okay, you know the z parameter, you know the y parameter. Now the question is you need to find your h parameter. Okay, so how you will do it? Prasanna, what you have written the notes now for for h parameter. Can you tell me the what is the exact general formula of a h parameter?
V1 equal to H11 I1.
Wait. V1 is equals to H11
H11 I1 plus H12 V2.
H12 V2 and I2 is equals to
H1
I1
H21 I1 plus
plus H22 V2.
H22 V2. Okay, we know what is H11. H11 is what? H11
V1
is
by I1.
V1 by I1
V2 equals to 0.
while making V2 is equals to
V2
0.
equal to 0.
So apply the condition and get the result. If you will apply the conditions while making your V2 is equals to 0, you will make it as a short circuit, right? Is it correct? If you will make it as a V2 is equals to 0, you need to find the value of a V1 upon I1. Am I right? Okay, V1 upon I1. So now take it as a x value here, your reference value. Apply the nodal analysis. So you are getting V1 minus, if you are considering some current from this side, some current from this side, some current from this side. So your incoming current is what? Incoming current is I1, right? Right now your incoming current is I1 and these two are leaving current. Okay, so incoming current is I1, that means I1 is equals to this current plus this current. And what is the value of this current? This x minus 0 upon 10. We took the node value x plus what will be this current? This will be x minus 4I1 divided by 2. Okay, so what you are getting from here, x plus 5x minus 20I, and this is 10, so 10 is coming here. So you are getting the value of 30I1 is equals to 6x. So x is nothing but it's a 5I1. Okay, the value of x you got as a 5I1. Now what you need to find now? You need to find V1 upon I1. So what is the value of I1? I1 means what? This I1 current represent what? V1 minus x divided by 3 is I1, right? Substitute the value of x in this. So V1 minus 5I1 is equals to 3I1. So V1 is equals to 8I1. So V1 upon I1 is equals to 8. That is your H11. You got the value of H11? Prasanna, understood? Priyanka, Priya, everyone?
Yes, sir.
Okay. Guna, you understood? Okay. So, okay. Yeah. So now you guys have to tell me. We know the value of H11. Okay. So same thing we have to implement in the same way. Now let me select. Now in a same manner you need to find the value of H12. So what can be the H12? H12 is V1 upon V2 while making I1 is equals to 0. Am I correct? V1 upon V2 while making I1 is equals to 0, you will get the value of H12. So apply the things. Your I1 is equals to 0. If it is 0, that means this is short circuit. It's simply a wire. Okay, and for that you need to get the value of a ratio between this and this. Okay, same concept apply. Take X node here, and if it is coming 0 like this, so if you'll apply the KVL, what you will get? Minus V1 plus 0 into 3 plus X is equals to 0. So V1 is X. So this is nothing but this value, this X is representing your V1 only. Okay, and V1 minus this is your V2. So V1 minus V2. V1 minus V2 is what? V1 minus V2 is V1 minus V2. V1 minus V2 upon 2. You are getting wait, this current is moving from this direction. Okay, so V2 minus V1 is what? Is nothing but it's I2 upon 2 ohm. Okay, and the same current will flow in this. Okay, these is flowing because this is 0, so the same current will flow in this. Okay, so the value of I2 will be same as V1 by 10 is equals to I2. Okay, substitute the value of I2 in this. V2 minus V1 by 2 is equals to V1 by 10. It will be 5 V2 minus 5 V1 is equals to V1. You will get 5 V2 is equals to 6 V1. So V1 by V2, what we are getting? V1 by V2 is 5 by 6. Okay, everyone, or any doubt? Anish, any doubt in this?
Yes, sir. 5 by 6.
5 by 6 we are getting, Anish? Okay.
Yes, sir.
You understood this one?
Yes, sir. I understand.
Okay. So Anish, means like we got the results of V1 by V2, that is H12. So in the same manner we have to find the value of H21. How will you solve this?
I2 upon I1 V2 is equal to 0, sir.
Okay. H12. Okay. So for H21, what we have to take? First, let me take another section. Might be see this. Okay. We have so wait. Yeah. So we have to find the value of H21. Okay, so if you have to find the value of H21, what will be the value of a H21? H21 is representing what? I2 by I1 while making V2 is 0. I2 by I1 while making V2 as 0. So V2 is equals to 0. So how can we solve? You have to take V2 as a 0. So just make it as a 0. It's a short circuit. Now you have a V1, you have to find the ratio between these I2 and these I1. So same concept, take it as a X, it's a 0, V1 minus X upon 3, some current is coming from this. So incoming current is what? This I1 current, that is V1 minus X by 3, and again another current is, incoming current is V2 minus X plus 4 I1 by 2 plus it's equals to X upon 10. Okay, so we did the KCL. So by solving this we'll get 2V1 minus 2X plus 3V2 minus 3X plus 12 I1 is equals to 6X by 10. Okay, so solve this equation, what you will get it? Anyone can say what will get the resultant equation? Or we can do one analysis like this. Okay, suppose this is our I1 current, this is our I2 current. Okay, first apply KVL here. You will get minus V1 plus 3I1 plus I1 plus I2, I1 plus I2 into 10 is equals to 0. So V1 value we are getting as a 13 I1 plus 10 I2. We got the value of a V1, that is 13 I1 plus 10 I2. Now apply the KVL in this branch, that is minus V2. Minus V2 is nothing but is 0. Okay, plus 2 I2 plus 4 I1 and take it as a voltage, in terms of voltage, that is or you can consider it like okay, let me consider it like in this term only, that is I1 plus I2 into 10 is equals to 0. This is 0 and 2 I2, we got the result, 2 I2 plus 4 I1 plus 10 I1 plus 10 I2, 10 I2, 10 I2. What we are getting here? 10 I2 is equals to 0. Solve this equation and tell me what is the value of a I2 by I1. Anyone? Solve this equation. By one equation only we get the result. We don't need to require this kind of a things. This is not at all required. So this is not at all required. By solving this equation only we'll get the result. Okay. So tell me anyone what are the value of I2 by I1 from this equation? This is 2 I2, 10 I2, 12 I2 we are getting. This is 14, so it is equal to minus 14 I1. So I2 by I1 is equals to minus 14 by 12. So this is what? This is your H21. Prasanna, got it? Prasanna, have you understood? Or any doubt? If any doubt, you can ask. Priyanka, any doubt? Anish, it's clear?
Yes, sir. Now clear, sir.
Okay. Prasanna, you want me to repeat this again, this section? Or it's clear?
Clear.
Okay. So we got the results of this. H11 we got, H12 we got, H21 we got. And now we need to find the value of H22. H22. So how can we find the value of H22? See. And yeah, see. So can anyone tell me what is the value of H22? H22 is
I2 upon V2, I1 is equal to 0, sir.
I2 upon V2 when I1 is equals to 0. Okay. So if H22 is equals to I2 upon V2 when I1 is equals to 0, what is the meaning? This branch current is 0. And we need to find the value of I2 upon this V2. Okay. This if this branch current is 0 means this is 4 into I1, that is 0. So that is, it is a short circuit. Apply the KVL and get the result from here directly. So what is the current? Means I2 current is coming in this, and if it is 0 current, so only I2 current will flow. So minus V2 plus 2I2 plus 4 into I1 is 0. So 0 plus 10I2 is equals to 0. So V2 is equals to 12 I2. So IT upon V2 is equals to 1 upon 12. Okay. So this is our H parameter. Can anyone tell me what is the value of H11 we got? H11. What was the value of H11 we got? H11 was 8. Okay. H11 was 8. Okay. Can anyone tell me what is the value of H12? H12, it's
5 by 6.
5 by 6. So in a point form, convert it into point form. Is 0.833, right? 833. And what is the value of H21? Minus 14 by 12. It's minus 1.166. Minus 1.166. Okay, minus 1.166. And what is the value of this? 1 by 12. 1 divided by 12. So it's 0.0833. You know, we got the result of a H. Now, if you know the value of H, you can find the value of a G very easily, because G is nothing but H inverse. So what will be the value of a G? G value will be what? It will be 0. We are doing just inverse. So you need to find the inverse of this. So first find the determinant. 8 into 0.0833 plus 0.833 into 1.166. So you are getting the determinant value. Determinant of H is 1.633. Change the 0.0833. This will be 8. This will be minus 0.833. And this will be 1.166. All are divided by 1.633. So you got the value of a Z. 0.0833 divided by 1.633 minus 0.833 divided by 1.633, and this is 8 divided by 1.633. So we got Z parameter, we got y parameter, we got h parameter, and we solved z, y, h is done, and we got the z parameter. Now the remaining part we'll do in tomorrow lecture. Okay, so we did this numerical, means up to this we had completed z, y, h and z. For T network we'll see tomorrow. Okay, so I already recorded the classes, 1 hour 45 minutes. I will upload somewhere and I will. Okay, so thank you very much. I hope you like this session.